So now that we've gone through, we created our first probability distribution table. Again, I'll scroll up a little bit, right? We were talking just about how to roll 2 dice, right? The sum of 2 dice. So here's my probability distribution table. We can now talk about the expected value. So the expected value, or the mean, one and the same, of a discrete variable is the long-term average we would expect to see if repeating the experiment over and over. And remember, if we recall the law of large numbers, right, that if you just do an experiment for, 10 times, but if you do an experiment for 1,000,000 times, right, the experimental or probability sort of reaches the theoretical probability. So the mean, or the expected value of the experiment, is denoted by the Greek letter mu, or e. To find e, simply multiply each value of the discrete random variable by its probability and then add up all of the products. This is frequently done using an expected value table. So I have, right, the mean is, right, so it's the sum of all the x values times their probabilities. I have the variance and the standard deviation, which we will talk in just a minute in the next example. Again, where x is the value of the random variable and p of x is the probability corresponding to a particular x value. So we want to find the mean, or the expected value for the variable sum, which is observed in the experiment of rolling 2 dice from above. So I'm just going to rewrite the table that we had, right? So I had my x and I had my p of x, right? And so we said the x was the sum of the numbers on the 2 dice. So I had 2 through 12. So 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. And again, this is just from the previous page, so I'm just sort of recopying it. So the probability of rolling a 2 was 1 out of 36. And we had 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, and then, let me just double check, 6 out of 36, and then we started going back down. 6 out of 36, and we had 5 out of 36, 4, 3, 2, and 1. Okay. So what I'm actually going to do is I'm going to create a third column. And so this third column is going to be x times p of x. This is going to set up how we can find the expected value, or the mean, of the distribution. So what I do is I take x times p of x. So I would take 2 times, right, 2 times 136, or this would be 236, right? And I can do this, so 3 times 236 would be 636. 4 times 336 would be 1236. The next one, 5 times 436 would be 20 out of 36. So remember, I'm really just multiplying the whole part, right, with the numerator of the fraction for the probability. So I'd have 30 out of 36, 42 out of 36, 40 out of 36, 36 out of 36. And then I have 30 out of 36, 22 out of 36, and 12 out of 36. Okay, and so now what we do is we want to add all of these together. And you may have noticed I didn't simplify, and I did this on purpose, because as long as they all have the same denominator, all you need to do is add up the numerator, right? So I'll just do this in my calculator, right? So I have 2 plus 6. So all I'm doing is adding, let me highlight here so you can see what I'm doing. I'm adding up just the numerators, and then I'll write this all over the 36. So I'm just adding up these numbers here. So 2 plus 6 plus 12 plus 20 plus 30 plus 42 plus 40 plus 36 plus 30 plus 22 and plus 12. All right, so I'll get my sum here. So 252. All right, so let me go back. So I'd have, right, 252 out of 36. And so we can actually, right, figure what this out. So 252 divided by 36, right, gives me a mean or an expected value of 7. So you could say, so here, let me write this on here. So the expected value, E of x, would be, right, 252 over 36, which would be 7. And again, this is also equivalent to the mean of the distribution. So we would say, right, the expected value of the mean would be 7, which again makes sense, right? 7 is the most common way to roll a sum on 2 die. Okay, so our next example is going to be how we find the standard deviation for the variable sum in the experiment of rolling 2 dice. And I'm actually going to stop the video here, and we'll talk about this next example in the next video.